All right, so this is 6.2b notes, and what we are going to be talking about here, it's this big, colorful 5 letters here in the middle, CPCTC. Okay, what it stands for is corresponding parts of congruent triangles are congruent. Okay, corresponding parts of congruent triangles are congruent. And what it means, all right, is that we can prove that corresponding sides or angles of 2 triangles are congruent by proving that 2 triangles are congruent first. Now, as we've noticed over the units we were working on congruent triangles and through our proofs the other day, we can prove triangles are congruent with a limited amount of information, okay? If we only had 3 facts and they're the right 3 facts, we can use those facts to determine if the 2 triangles are congruent. Now, once we've proven they're congruent, that proves right away that all 3 angle pairs are congruent pairs and all 3 side pairs are congruent pairs. So that gives us, basically tells us if we know the triangles are congruent, we've got 6 pairs of things that will be congruent. All right, and the reason why we know that is because of CPCTC. Okay, so even if we're not given the fact that 2 things are congruent, once we've proven the triangles are congruent, we know that they are. Okay, so let's look how that will present itself within a proof. All right, so here we have given information. It says side WX is congruent to side XY, which is congruent to side YZ, which is congruent to side ZW. All right, so if I go ahead and mark these down, so we're given that all 4 sides are congruent. Okay. Well, right away that tells me this is either a square or a rhombus. I'm not sure which one. It looks like a square, but I don't think I can prove that. Maybe I can. But we're not trying to prove that. What we're trying to prove is that angle W is congruent to angle Y. Now, we're not given that information, right? There's no transversal that can let us say that based on parallel lines. Again, we can say they look like right angles, so if they are, they'd be congruent, but we don't have enough information to say that they're right angles. Okay? So let's see what we can figure out. I do see that we've got a shared side between these 2 triangles. All right? So if I can somehow prove that this triangle is congruent to this triangle, then I should be able to show how angle W is congruent to angle Y, because then they'd be paired up congruent parts. All right, so we're going to start off with our given information. So we're good there. We got that given information. All right. We know all the sides are congruent to each other. Basically, they're all the same length. I also know that ZX is congruent to ZX, and that's the reflexive property. All right. So what we have here is we actually have the fact that we've got one pair of sides, which is actually these 2. We've got another pair of sides, these 2, and we've got a third pair of sides, the shared side. We can say these 2 triangles are congruent by side, side, side. So I'm going to go ahead and say that. Triangle, let's do XYZ is congruent to triangle ZWX. And really, it doesn't matter if I say ZWX or XWZ. In this case, I just need to make sure that the middle points are these points that aren't along this line. So in this case, W and Y need to be the middle points, okay? Because I started with Y in the middle. And we said these are going to be congruent by side, side, side. Now that we know that the triangles are congruent, we can say that angle W is going to be congruent to angle Y, and our reason is CPCTC. Corresponding parts of congruent triangles are congruent. Once we know the two triangles are congruent, we know that all the angles that correspond to one another will also be congruent. We could mark all of these angles. Okay? And again, this isn't enough information to say that that this is a square. We're not trying to prove that anyway, but we don't have enough information for that. We would have enough information to say that it's a rhombus. All right, but again, we're not trying to prove that either. So this is how we would prove angle W is congruent to angle Y. Okay, and what we're doing is essentially we're doing the same kind of proof we were doing the other day. We're just adding one more step. Okay, if we're trying to prove for a part, not the triangles are congruent. If we're trying to prove for a part, all right, you're going to have to prove the triangles are congruent first, and then you can add this last step on with CPCTC. Okay, let's look at one more example. All right, given E is the midpoint of BC and AB is parallel to CD, prove that CD is congruent to AB. All right, let's mark down our given information here. E is the midpoint of BC, so E is the midpoint of this segment that goes left to right. Being a midpoint, that does tell me that I'll get two congruent segments. AB is parallel to CD, so these two sides are parallel to one another. We're not given that they're congruent, but we do know they're parallel. And parallel lines with transversals allows us to get some alternate interior angles. So we actually could get a couple different pairs of alternate interior angles from that. And lastly, it's not in the given information, but I do see we have a pair of vertical angles, all right, which does give us three congruent angle pairs. Now, if you remember, angle, angle, angle is not a congruence theorem. That's a similarities theorem. So we couldn't use that here to prove the triangles are congruent. But we do have this one pair of sides that we're going to be able to use based on our midpoint. That should be enough. Okay, let's go ahead and write out our proof here. So I'm going to try and make this a little neater. All right, so statements, reasons. I'm going to start off with my given information. E is midpoint of BC. I'm going to go ahead and put the other statement right here with it. And AB is parallel to CD. Okay. Given. All right. Let's see. I'm going to go ahead and try and get some of these other things that I had marked on here because they aren't given information, but they are definitely things that we can extrapolate from the given information. Let's get these congruent sides. So 2, I can say that BE is congruent to CE. And if you remember, the reason why we could say it is the definition of midpoint. Okay, definition of midpoint. So we got a pair of sides. Put a little S here. All right, let's get our, I really don't need both these, but I'm going to go ahead and put both pairs on there anyway. We actually could use angle, side, angle, or angle, angle, side in this case. So we got a couple different options for proving the triangles are congruent. Let's see. So I'm going to say angle A is congruent to angle D, and angle B is congruent to angle C. Now I can say both of these in the same step because I'm going to use the same reason to prove that they're congruent. And that's because alternate interior angles are congruent. All right. When you got your parallel lines, alternate interior angles are congruent. All right. So that'd be an angle and an angle. I actually don't need any more information in here to prove the triangles are congruent. I could put my vertical angle pair in here, but I don't need it. I can use angle, angle, side. So I'm going to go ahead and prove the triangles are congruent. Triangle, let's go ABE is congruent to triangle. Now I got to make sure I match these up right. ABA, so that goes single, double, triple. So single, double, triple. DCE. And angle, angle, side is what we use. The two angles that are alternate interior angles, I use those two and the side that we got from our midpoint. All right, so that covers our congruent triangle part. Now, once we know the two triangles are congruent, I know that all the corresponding parts are congruent. So I can now prove that CD is congruent to AB. And I know that because they match up right here, AB and CD. They're written right next to each other. I know that they are corresponding parts to one another. I'm going to write it just like I'm trying to write up here in the proof part. CD is congruent to AB. A reason? CPCTC. Okay.